Good evening. Welcome to my Mathematical World, episode 2. This is a very short video. You may not agree with me. Perhaps I'm mad. But I want to talk about numbers and how they mislead us, or at least how they don't serve our intuition very well. And to do that, I want to talk about the question, how big is a million? Now we know how to write a million, obviously. 1, 0, 0, 0, 0, 0, 0. But do we have any real intuition of how large it is? Well, part of my argument is that the way we write numbers in base 10, 1, 10, 100, 1,000, and so on until we get to a million. The trouble with it is that although it's incredibly efficient in terms of calculation, that the numbers only get a little bit larger, even though the numbers they represent, in other words, the actual numbers of entities, whether it be marbles or grains of sand or pounds or dollars or whatever, get bigger much more than the numerical representation, than the number as we write it seems to tell us. And just to, as you might say, illustrate this, and I know this looks terribly boring, but there is a point to it. Let's choose a really big blob. Let's suppose that we go from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the difference between 1 and 10 in notation, the way we write it down, is just the difference between 1 and 1, 0. 1 and 1, 0. But if you think about it, to go from 10 to 100, that just involves adding 1 naught, just as this involved adding 1 naught. But the difference between 1 and 10 is immense. The difference between 10 and 100 is even more immense. Bear with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know this looks terribly boring, but actually there is a reason for doing it. Because if you have never actually done this, you probably have never appreciated just how big 100 is. How many have I done here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, that's 100, all right? It takes 10 times as long to make 100 dots as it takes to make 10 dots. That block is 100. But imagine I now said to you, okay, it was really boring, wasn't it, watching me do all those dots, and you were sitting there thinking, what on earth is he doing? Now just imagine that we replace every single dot with 100 dots. Every single dot with 100 dots. That, no, that's not a million. That's nowhere near a million. That's just, or what is it? It's 100 times 100. It's replacing every dot in our 100 grid with 100 more dots. That's only 10,000. How long would that take you? Well, 100 times as long as it took you to draw the grid of 100, and that was bad enough. But if you had done that, if you had something that was 100 by 100, so in other words, you had something that had 10,000 dots, and you were then to replace every single dot, with 100 dots in your grid of 10,000, then and only then would you have 1,000,000. 1,000,000 is 1,000 by 1,000. In other words, if you were to draw it, you would need to do 1,000 dots that way, and you would need to do 1,000 dots that way, and that in total would be 1,000,000. It's big. I would urge you to get a piece of paper and fill in, maybe graph paper or something, fill in a 10 by 10 grid with 100 dots. See how long it takes you, and then think, okay, now I'm going to do that 100 times. That's not 1,000,000, that's 10,000. And now I'm going to do that 100 times. All of it, all 10,000 dots 100 times. That's 1,000,000. That's a lot. Thank you for listening.